Welcome to a small talk about a reference frame subjected to rotational movement. This is a topic of the class of dynamics of the rigid bodies, and it's an interesting topic. First, we are going to define what is a reference frame. A reference frame, put it simply, is only a person with two things, a clock and a ruler. We are going to assume that with those objects, the person is able to define the position vector of any point P as a function of time. That's enough for our reference systems. But associated with the reference systems, we can have different types of coordinate systems. Here we are using a Cartesian coordinate system represented by the coordinates x, y, and z in red. But we can have also a cylindrical coordinate systems represented by the angle phi in blue, the distance r, and the distance, the coordinate c. And also we have a spherical coordinate system represented by the phi in green, the angle theta in green, and the distance r in green. In what follows, we're going only to use the Cartesian coordinate systems. Now we can consider two different reference frames. One we can consider located in point O, a fixed reference frame, and another one in P. This reference frame is going to move with the velocity and acceleration of point P. Using this approach, we can consider what is the velocity of point Q as seen as the reference frame fixed in the earth in point O, and also the moving reference frames subjected only to translational motion located in P. This is what it needs in order to analyze the movements of rigid bodies subjected to planar motion. Now we have more complicated situations. Here we are going to have two different reference frames, one in red, fixed to the earth, whose origin is in point O, and whose axes are given by the angles, the axis x, x, y, and z. Okay. Notice that the axes x, y, and z are fixed to the earth because they are also fixed to the fixed body. Okay. In addition, we have rotating reference frames. The rotating reference frames is represented by this ellipsoid in blue. His origin is again the same origin in point O, and his axes are given by x1, y1, and z1. It should be noted that the axes x1, y1, and z1 are fixed to the moving body, and the movement of the body and also the moving of the reference frames is rotations around the fixed point O. In what follows, we are only to consider rotations around a fixed axis, but these results can be also generalized to a reference frame subjected to a rotational movement around a fixed point O. The main result is going to be what are the relationships between the derivatives with respect to time of a vector function beta as seen from two different reference frames. The fixed reference frame x, O, x, y, and z, and the moving reference frames denoted by O, x1, y1, and z1. In this figure, we have the following situations. We have two different reference frames. The persons on top of this structure represents a fixed reference frame, a reference frame that is not moving with respect to the earth, and these other persons that is rotating with the table is going to represent a reference frame subjected to rotational motion. In this particular case, the rotational motion is going to be rotations around the vertical axis. We are going to consider is going to be the motion of a small particle represented by a rat that tries to escape frightened in the simplest, in the fastest possible way. And the fastest possible way represents a line along the carousel that is rotating around the z-axis. As a way of example, we are going to look into the motion of the rat with respect to these two reference systems. You can see that the trajectory of the rat, as seen from the moving reference system, is a straight line along the green vector. However, the trajectory of the rat, according with the fixed reference frame, is an spiral that takes into account the rotation of the carousel. In what follows, we are going to see how to relate the velocity and the acceleration of the rat as seen from the fixed reference frames and from the moving reference frames. The result finally is going to produce what is called the Coriolis acceleration.